Okay, guys, welcome back. Sorry that I've been out the last couple days. I've had a couple sick girls, but I will be back tomorrow to do our lesson. So hopefully you are watching tonight and following along. Today, the problems that I'm doing are in your problem set, so you can stop and work them with me. Please remember that while I'm doing the videos, if you don't understand something, use that power of pause. Use that power of rewind. Go back and make sure that you re-watch it and that you're just listening to my words and seeing where I'm pulling the numbers from. Remember, sometimes you just have to trust your coach that what I'm teaching you is the right way. And if you follow the same steps, that you will get the right answer. So just remember that as you watch this, because we are getting into word problems today, and I know that a lot of you, that overwhelms you and you immediately shut down, but I want you just to follow along with me today. You can do this. I know that you can. So just pay attention to what the words that I'm pulling out and the strategies that I'm using today so that you can be successful. Okay, so again, our objective is that we're going to solve word problems involving the volume of rectangular prisms with whole number edge lengths. Okay, so we know what word problems are. We've been working with those for a while now. We know what volume is. The formula for volume is that length times the width times the height. Or if they give us area, that we would multiply that just times the height. Rectangular prisms is what we've been working with this entire time thus far. Maybe a couple cubes thrown in. But it looks like today we're going to focus on those rectangular prisms. And that the edges, so those numbers that we're going to use today, are all going to be whole numbers. That means no fractions, no decimals. They're going to keep it simple as we get started here and just focus on whole numbers. So let's go ahead and get started on today's lesson. All right, so again, this is in problem set 7 for you so that you can follow along with me. All right, so it says Jeffrey's first planter is 8 feet long and 2 feet wide. Already I'm thinking area because I hear long and wide. The container is filled with soil to a height, there's my other magic word, of 3 feet in the planter. What is the volume of soil in the planter? Okay, so I'm going to give you a couple of strategies today. The first strategy, I'm going to come back to my home page here. The first strategy that I'm going to give you is that we're going to model the problem. All right, so maybe for you that means draw. Maybe for you that means build. Remember that building is not our most efficient method for solving those, and so we want to move away from the building and into the drawing. But if you still need to build, then that's the very important part for you to do. And so when we get to school tomorrow and you have your Unifix cubes, you can definitely build these problems. The second thing that we're going to work on today is calculating. And then with a statement. And we'll talk about what that means as we get going here. And then the third thing that we're going to do today is that we are going to make sure our answer is reasonable. That's one of those strategies of a good mathematician. And we'll put a question mark there at the end. And you've seen me before catch myself several times because I think about, well, that can't even be close to being right. And so it means we have to stop and we have to slow down. It does not mean that I'm going to be able just to pluck out 3 numbers and jump down here to multiplying. I need to be able to model the problem. So let's come back to this first problem here. So it tells me that I have a planter. So on the first page, it told me my objective that we're going to be dealing with rectangular prisms. Now, I don't need to have a ruler out, and I don't need to draw this to scale or anything like that. What I do need to do is I just need to give myself a shape. I know that in the problem, it tells me that this is 8 feet long and that it's 2 feet wide. Now it doesn't matter, you don't need to get caught up in which number goes where, which one is the width, which one is the length. It's just a matter of that area being the length times the width. So remember when we were doing this in class, we started with that base and then we added the layers on the top. So the oh my goodness, commutative property tells me that 8 times 2 and 2 times 6, or 8 times 2 and 2 times 8, my goodness, are the same thing. So it doesn't matter which order I put them in. But that's going to be my planter. And then it's filled with soil. So I'm just going to demonstrate that. I can color in my soil. It doesn't need to be awesome. It says that it has a height of 3 feet. So this is my soil. So now I am going to go ahead. My first one was that I model the problem. That was step 1. Step 2 is that I calculate with a statement. So that means I'm going to find the answer, but I'm not just going to find the answer and write the number. I need a statement. So I have 8 feet times 2 feet times 3 feet. And so I have, let's see, 8 times 2, that's 16. 16 times 3 equals 48. So there's 48 cubic feet. But that's not my answer. My answer is, or my step is that I have to write a statement. So I'm going to, it asks me what is the volume of soil in the planter. So I'm just going to answer them. There is 48 cubic feet of soil in the planter. Okay, and now my third step says I need to ask, is that reasonable? All right, so I'm going to think of this kind of like as a fish aquarium. And so if I had 8 feet, which would be about 2 people laying down, and 2 rows going back, and that was stacked 3 layers, does that make sense? Well, 8 is close to 10. 10 times 2 would be 20. And then 20 times 3 would be 60. So considering that those are whole small numbers, that makes sense. 48 is close to 60 in the sense that if I had gotten 480 or 4, I would know that that's not correct. But because this should be about 60, 48 makes sense. So that tells me that I am done with this problem. So all I did was read the problem, find my measurements, label a picture, solve it, and write a sentence. All right, so let's go on to number 2. Looks like we're working with Jeffrey today. Jeffrey wants to grow some tomatoes in 4 large planters. Now, if you are following along with me in your problem set, you will notice that there's 4 boxes for you to draw this into. So as I am kind of working through this, I will try to do that as well. So I know I'm going to have to draw, so I'm going to go ahead and just kind of say planter A, planter B, planter C, and planter D. I could say 1, 2, 3, 4, but since I'm doing math and I'm working with numbers, I'm going to use letters to label my boxes. So he wants to grow some tomatoes in 4 large planters. Okay, so this is where I'm going to draw my planters. He wants each planter to have a volume of 320 cubic feet. But he wants them all to be different. Show 4 different ways Jeffrey can make these planters and draw diagrams with the planter's measurements on them. All right, so I want you to think about what we've been given. All right, and I want you to think of it in terms of, is it the part and we're trying to find the whole, or have we been given the whole and we're trying to find the part? So like if I were drawing my tape diagram Do I have how many boxes there are, or what's in each box, or do I have the total? And in this case, I have the total. So I have to come up with some parts. All right? So I want to think of this 320. I'm going to now just come up with some puzzles. So you might have out your multiplication sheet at this time, and you're going to look for some ways to make 32, and I'm going to rewrite this as 32 tens. Okay? So if I wanted to make 32, I could say, I know 4 times 8. Okay? Now that's only 2 measurements. How many measurements do I need to have a volume? I need to have 3. So I could say that it is 4 times 8, which is 32. So then I could just say that it's 1. That would be 1 box that I could make. So what that looks like is that I'm going to make my prism. Okay, and I might say, okay, well, 8. I'm going to make this 1. We'll just say it's 1 layer, and that the height is 4. And we're measuring in feet. So when I multiply that together, 8 times 1 is 8. 8 times 4 is 32. So that would work. All right, so now I need to think about another way that I could make this. This time, I could think about, let's see, I'm going to think 2. 2 goes into 32 16 times. So instead of using the same number again with 1, I'm going to break this down. And I'm going to say 4 times 4. So now, instead of saying that, I've got my 3 numbers. So I could say, let's see, let's change up the shape of this just a little bit here. Let's say that this front part is going to be 4, so I've used that number. Let's say that the length here is going to be 2, so I've used that number. And then let's say that the height is going to be 4. So I've used 3 numbers, all of them when they equal to 32. Oh, but it needs to be 32 tens. So I'm going to have to make one of them a 10. So here I have 4 times 2 is 8. 8 times 4 is 32. So in order to make that tens, I need to add a 10 somewhere. So I'm just going to make that a 20. So 4 times 20 is 80. 80 times 4 is 320. So see my reasonableness? I got a little bit carried away by breaking this into 10. So up here, I'm going to go ahead and I'm going to say that this is 80 feet. So now I have 80 times 1 is 80, and 80 times 4 is 320. All right, I almost would have missed that problem. It's a good thing that I was thinking about that as I was working it, because I missed that whole part about the tens. So this time I'm going to keep it 320, so that way I don't get myself confused. And I'm going to think about, it ends in a 0, so I know that 5's going to go in there. So I'm going to say 50. So 5's going to go into 320. Let's see, 50 into 320. 5 goes into 32 6 times. So that's not going to work, because even though it ends in a 0, I was thinking of 5. I'm not putting those tens on there. So let's say 20. All right, so 20 goes into 320 one time. All right, 1, 2, 0, 6. So my answer here would be 16. 20 times 16. Well, I still only have 2 numbers, so I need to break this down into something else. So what if I take this 20 and I say, okay, so this 20 is the same thing as 4 times 5. So 4 times 5 is 20, 20 times 16. So because I just messed that up, I want to make sure I've got that right. 6 times 0 is 0. 6 times 2 is 12. I'm now multiplying by 10, so I'm going to put my 0 there. Oops, sorry, I'm out of your view. 1 times 0 is 0. 1 times 2 is 2. 0, 2, 320. Okay, so that works out. So I could say that in my next box, that I have, this is going to be 16. That's the long one. So I'll say that's 16. I will say that this here is going to be my 5. Okay, so I've used 5, I've used 16. Now I need to come back over here and I need to use 4. So I'm going to say that's 4 feet tall. So now when I multiply those together, I will get 320 cubic feet. All right, so now I'm going to do one more here. Let's see. How about I haven't used a 10, so let's do that. So I know 10 times 32 is going to equal 320. So now I need to break one of those down. I might break down, I've already used 4 times 8. I've used 16 times. So I'm going to break down this 10, and I'm going to say 2 times 5. So this box is going to be really, watch this. It's going to be 2 here. I'm going to make this 32. All right, we'll change the shape up a little bit. So if I've used 2 as this line here, and I've used 32, the only number left is 5. So I gotta say that the height is 5. And when I do that, let's see. 2 times 32 is 64. And then 64 times 5. Let's see, equals 320. Perfect. So those are my 4 shapes. So it says show 4 different ways Jeffrey can make these planters and draw diagrams with the planter's measurements on them. So I can come over here now and I can solve my work. So the volume equals length times width times height. Here, the volume is going to equal 80 feet times 1 foot times 4 feet. And that equals 320 cubic feet. Here, volume equals length times width times height. So volume equals 16 feet times 5 feet times 4 feet. And I already did the math, so that equals 320 cubic feet. So all I'm doing now is I'm showing my work. So I'm going to come do this side over here. Volume equals length times width times height. Volume equals 4 feet times 20 feet times 4 feet. And that equaled 320 cubic feet. And I'm doing this because I've already done the math down here. Now I'm just showing anybody that looks at this that doesn't know how to find volume. They could look at my formula here, volume equals length times width times height, and see where I've gotten those numbers. And they could plug them in and they could solve this for themselves. So it's kind of like you're becoming a teacher here by writing them some equations to help them show how you got your work. All right, now this one was a little bit long and it took a little bit more time and it took a little bit more thinking, but you guys can do this. So just make sure that you're taking the time to read the question and understand what's being asked of you. It's going to take some stamina to get through these because remember, we're in 5th grade now and we have a lot of schema that we need to work through and use in order to solve these. And so it's no longer going to be just a pick out 2 numbers and the operation and bam, you've got the solution to a word problem. You're going to have to do some work with these. This is more of a show what you know, and the more you show, the more that I can see that you know. So you want to make sure you take your time on these. All right, so let's go ahead and let's take a look at number 3. Again, this is in your problem set if you're following along and writing down the answers. Jeffrey wants to make one planter that extends from the ground to just below his back window. The window starts at 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so it is not taller than 3 feet. Explain how you know. Okay, so what I'm hearing, there's quite a few things in here that I'm hearing. And so I know Jeffrey's going to build this planter. Planter might be where you keep some flowers. I have a planter where I keep herbs on my back porch. So it's a planter. It's a big box. And it's going to come from the ground. So I'll kind of draw some grass down here. And it's going to come to just his back window, okay? So maybe he wants to look out the window and see the flowers. This has got to have some legs on it. So it's going to start 3 feet off the ground. Now, that looks like it might be important, but it's really not. It doesn't matter where he starts it off the ground. What we need to know is that the planter cannot be taller than 3 feet. Okay, so see how I had to draw that picture and I had to visualize what it was really asking me? So I know that I need to have 3 feet times some number, and that's going to equal 36 cubic feet of soil. All right, so since I'm going to have 3 numbers, I'm going to go ahead and I'm going to divide it. That 36 cubic feet by 3. And when I do that, I'm going to get 12. Okay, if you're wondering how I did that, 3 goes into 36, 3 goes into 3 one time. I subtract. I have 6 ones. I can make 2 groups of 3 out of those 6 ones. So that's where my 12 is coming from. So, because I know that one of these is 3, I need these 2 numbers here to equal 12. So I'm going to say 4 times 3. I could have chose 2 times 6, but I'm just going to choose 4 times 3. So let me check my math really quick. Volume equals length times width times height. All right, I have, let's see, 3 feet times 4 feet times 3 feet. That gives me 3 times 4 is 12. 12 times 3 equals 36 cubic feet. All right, explain how you know. So this is going to take some writing. It's not just, this is my answer because I worked it out. Those are not 5th grade answers. That's not 5th grade work. So you want to make sure that you are explaining yourself so that your teacher, for example, me, knows how you got your answer. So I'm going to kind of restate the problem. So since Jeffrey wants to build a planter with a height of 3 feet, so I'm just restating what's in the problem, and a volume of 36 feet. So see already, if you were grading this, wouldn't you be like, wow, this person really knows what they're doing. Look at how much they wrote. I didn't have to come up with any of that, friends. It's all right there in the word problem, okay? So when I'm explaining, I want to tell my reader, where did I get these numbers from? So I'm just pulling them right from here. I don't even have to think about that. That's right there. So now I'm going to say the work that I did. So because he wants to have a height of 3 feet and a volume of 36, then the base should have an area. So remember, the area is that length times the width. Like if I was looking at the inside of this planter and I was looking at the bottom of it, okay, 3D down in there, I'm looking at the bottom, that's the area, right? We started off the unit with this, length times width. And we decided that that should have an area of 12 square feet. I drew a planter with a length of 4 feet, a width of 3 feet, and hopefully you know this last part because it's what it told us, a height of 3 feet. That, friends, is how you explain, okay? All I really did was that I divided 36 by 3 and got 12, but they don't know what that means. I have to tell them why I got 12 because that's what I needed for that bottom to be. I knew I had the height. I knew I needed the length times the width. So I could be fancy as a mathematician and go ahead and call that the area. And so I knew I needed an area of 12. So then I just tell them. So I drew a planter with a length of 4, a width of 3, and a height of 3. So if you notice, this has got a little bit of writing to it. It's got a little bit of length to it. If you have one like this, use this as a model, friends. When you're doing the homework section, use this as a model. Like I've been telling you with these videos, you have the power now to pause this and look at what I've written. And as long as it's the same kind of problem, which it probably is on problem 3 homework, you can pretty much use these same words and just substitute the numbers for what they've given you. Okay, so work smarter, not harder. And we're training our brain. So the more you write like this, the more your brain will get used to it. And eventually you won't need to pause and write what I've written. Eventually your brain will know to do this on its own. But right now it's kind of like we're in the training wheels stage. And despite what you think, we all need to start with training wheels, okay? So these are your training wheels. So use this to help you answer homework problem number 3. Okay, so this is going to be our last one, but as always, our last one is a little bit of a doozy, so it's going to come in a couple different parts. All right, so I noticed that because it says 4A. So let's see what Jeffrey's up to now. So again, this is in your problem set if you want to read along with me. After all of this gardening work, Jeffrey decides he needs a new shed to replace the old one. His current shed is a rectangular prism that measures 6 feet long by 5 feet wide by 8 feet high. He realizes that he needs a shed, the shed with 480 cubic feet of storage. All right, so that's my situation. Okay, so let's zoom in now and see what we go do here. Will he achieve his goal if he doubles? Doubles means 2 times each dimension. Why or why not? So I'm going to use the number that they gave me and I'm going to multiply it by 2. So volume equals length times width times height. So it wants to know if I double each of these. So let's see, my first one is 6 times 2. Then that would be, the next one would be 5 times 2 because I'm doubling each measurement. And then finally I have 8 times 2. So the order of operations tells me I got to do what's in parentheses first. So 12 times 10 times 16. Okay, so am I going to have 480 cubic feet? So let's see. When I multiply by 10, I know I'm just going to move one place over on my place value chart. So I'm not going to use that right now. I'm going to use that at the end. And I'm going to multiply this 12 times 16. All right, remember it's multiplication, so it doesn't matter which one's on top or which one's on the bottom. We have no decimals, so we're just going to write it like this. 6 times 2 equals 12. 6 times 1 equals 6. Plus 1 equals 7. Now here I'm multiplying by 10, not 1. So I'm going to put that 0 there because I would shift place value. 1 times 2 is 2. Or I can look at it as 10 times 2 is 20. 1 times 1 is 1. So I add those together, 2, 9, 1. So I need 192, but I still haven't used, I've used that number and that number. I still need to multiply by 10. So if he doubles the length, he would have a shed with 1,920 cubic feet. All right, so let's see here. Let's write this as an explanation because it says why or why not. So did he meet his goal of having 480? No, he had quite a bit more. So Jeffrey's shed has 1,920 cubic feet when he doubles each dimension. All right. So, will he achieve his goal? Well, he only needs 480. He's got 1,920. So, I mean, I guess he's met his goal, but now he's got this huge shed that is almost 3, 4, almost 5 times the size that he needs. So that's really big. So when he multiplied each of these by 2, 2, 4, 6, that makes sense because it's about 6 times bigger than what he had. So, let's go on to part B and see what part B says here. After all of this gardening work, Jeffrey decides he needs a new shed to replace the old one. His current shed is a rectangular prism, 6 feet by 5 feet by 8 feet. Okay, that's the same thing. He realizes that he needs a shed with 480 cubic feet of storage. Okay, if he wants to keep the height the same, what could the other dimensions be so that he gets the volume that he wants? So, I know that he wants the volume to be 480 cubic feet. Okay? So, if he keeps the height the same, 8 times what? 2 numbers. So, I am going to take this 8 and I'm going to divide it into 480 and see what I get there. 8 goes in, if I have 4 blocks, I can't make groups of 8, so I would get 48, 6, 48, 0, 0, 0, 60. So 8 times 2 numbers that equal 60. So let's see. What can I get here? 8 times, let's see. I gotta make this realistic. So he wants it to be 20 feet long and 5 feet wide. So 2 times, so let's see. Let's do 10 feet long and 6 feet wide. So when I do that, 8 times 10 is 80. 80 times 6 is 480. So he could easily do it that way. He could also, I'm going to put an or, you don't have to solve it both ways, but I could also say, what's another way to make 60? I could say 480 cubic feet equals 8 times, 20 times 3 doesn't make much sense just because that would not be a very big shed. That wouldn't be practical. So 5 goes into 60 12 times. So that makes sense. That might be a good size shed. And when I put 8 times 5 times 12, that gives me 480. So there's a couple different ways that you could solve this problem, just depending on how you want to break up that 60. But you have to keep in mind that this is where that number 3 comes in of, is it reasonable? If he wants a shed, then he doesn't want a shed that's going to be 8 feet tall, really, really tall, 2 feet wide, and then 30 feet long. Okay, that would not make any sense. So you've got to visualize and you've got to really evaluate what the problem is asking you here. So I'm going to answer my question because it says, what could the volume be? All right, so I'm going to scooch down here a little bit because I have written all over this paper. So since Jeffrey wants to double the volume of his shed and keep the height the same, he could, let's see, what did we do here? He could double the width. And keep the height, and keep the length the same. That would be this measurement here, so it depends on how you solved it, because originally my numbers were 8 times 5 times 6. So here all we did was we doubled his width. Here at my other one, we kept it 8, we kept it 5, but here what did we do? We doubled the length. Or he could double the length and keep the width the same. So he had the right idea on part A, where he knew that he was going to have to double something. That's why he was multiplying everything but by 2. But we've just proven here that he didn't have to double everything. But he did need to double one of those two, either the length or the width, in order to get that 480 cubic feet. So I'm going to zoom out there so that you've got the answer there. Take a moment to pause if you need to and copy that down. To copy that down before we move on to the next one. And you can use this to help you again in your homework. All right, so I'm going to move on, but you have the power of pause, so you just pause right here and write that down. All right, this is our last one for today. And we've got the same problem. And so it says, if he uses the dimensions in part B, what would be the area of the new shed's floor? Okay, so I actually came up with 2 dimensions for part B. So if I use this one here, where it is 8 feet times 10 feet times 6 feet, then this is the height. It's told me that, because he doesn't want to go higher than 8. So my area, this would be like the length, or the width. This would be the length. So to get area, I do length times width which is 10 times 6, which would be 60. Or if I did it the other way with the other formula that I used, the other dimensions where I had 8 feet, which is still the height, times 5 feet, times 12 feet, where this time I doubled the length. This is still the width. I know the area is length times width, which would be 5 times 12. And so the area, no matter what the dimensions are, would need to be 60. So, it asks me what would be the area of the new shed's floor. So I'm going to write that as a statement right after I put Grace's dress on. And I'm going to put, oh, sorry kiddo, there you go. I'm going to put that the area of the new shed's floor would be 60 square feet. All right, mathematician, that took a lot of work to get this far. Remember, though, to be accurate mathematicians, it does take time. These are not meant for you to fly through them. So hopefully by watching the video tonight and working the problem set, tomorrow you'll come in, remember, with your very specific questions, not I don't get it or how did you get, but by referencing the video, I saw that you put that number there, but where did this number come from? And just being as specific as you can to show me where your understanding is. When we come in tomorrow, we will do our fluency and warm up, and then we will get to the homework. You should be working on Zearn at home if you have some extra time. That's going to give you this extra practice for this unit, this module, and get you ready to go when it's time for the assessment. So you guys have a good night. I look so forward to being back with you tomorrow and seeing you, and thank you for all of your patience and understanding with the kiddos running around here. So you guys have a good night. I'll see you tomorrow.